Well, it's great to be here. It's just a year ago that I stood here giving some opening remarks at last year's Generative AI get-together. And it's brilliant to welcome you all to Jesus College. As Cassidy said, I'm principal here, and it's been great to see both college and university expand out, embrace the breadth and opportunity that is modern computational thinking. And in fact, this space, the Digital Hub, was built to reflect that opportunity. I also am a professor in computer science, where I've got a research group researching human-centered computing and AI. And I'm, as Cassidy said, executive chair of the Open Data Institute. So a number of hats, but in all of them, where the intercepts, the trajectory of AI is going, hugely relevant. I've been working in the field for 44 years. It seems absurd to be thinking that. It feels just deep history. But in 1978, when I went to Edinburgh's Department of Artificial Intelligence, we still thought we were at a leading edge of the audacious notion of building systems that could adapt, teach us something about our own cognitive processing. We could learn about how to build effective systems from our own ability to interact with the world. And that's always been a dream. It has gone through many iterations, many periods of being in and out of favor. But right at the moment, it is very much in favor. And of course, one has to pay tribute to the remarkable achievements of the field, particularly in the area of deep learning, deep neural networks. John Hopfield, Jeff Hinton, Demis Hassabis, Nobel Prizes in physics and chemistry. Now, there is debate about whether this is an appropriate award. I think it's absolutely brilliant for the field, and I think it speaks to a recognition that these approaches, these deep methods, this transfer of core ideas from physics, statistical mechanics, the application to 50-year-old problems, this is an achievement in and of itself. So huge congratulations to them and their teams, and collectively we should take a great sense of pride in those accomplishments. Now, we know that deep neural networks of sub-symbolic AI has exploded over recent years. Many different architectures, many different types of network have been developed, and you've not seen the last of this constant innovation over models. And if you try and keep track of the genealogy lines, you get these extraordinary timelines which almost struggle to keep up to where we are today. You know, lots happened in the 2023, but a hell of a lot happened in this past year with the release of Gemini, most recent Strawberry models. You've got this proliferation, not just within text, but multimodal models. And I just wanted in my opening remarks to pull out a few trends that I think we're going to see that I think are important. I mean, if you just take the llama speciation, you'll see that variants were built for different geographies, different regions, trained on Chinese. A big battle over whether those weights would be truly open, how they'd be released to the community. But these things happen, and suddenly we find huge amounts of innovation across these models. There is, interestingly, a very interesting debate, and I pointed to it last year when I was talking about what about the role of small versus very large models, small being just a few tens of billions of parameters. And there's a very recent paper it's a very recent, relatively recent paper last year from the DeepMind team looking at this trade-off space. What we're beginning to see is the field understand what the trade-off between the cost, the literal cost of building these models and training them, as against their performance, as against the amount of training they will require. And you start to notice that actually in some cases the small models can do really rather well. So it isn't one model to rule them all, certainly, and it is about understanding how to be smart. I mean, one of the things I often try and reassure my own DPhil students of here at Oxford is that, necessity is the mother of invention, and you will think of very smart ways to pare down, do much more with these models. This paper lays out a very interesting trade-off space in that regard. There is this debate I referred to earlier on about open versus closed. And so if relatively recently, we've been seeing some really remarkable performance on some of the benchmarks. Big Code, which is this very powerful set of ELO, basically ratings and rankings of the ability to do coding. And we're seeing that latest models, some of those open source models, are really up there. So this gives us a sense that we as a community are starting to understand what is in the open domain, what will be more intellectually protected. Nevertheless, there are remarkable results out of this whole speciation, this whole population of AI systems. We talk about applications. You'll be talking about it a lot today. This is just a slide from a recent presentation I was doing to, well, you might think, yeah, you wouldn't need asset management. Asset management, that people who are making investments on our behalf are looking at a whole range of application contexts for Gen AI, from portfolio management to risk management to fraud detection, investment research, trading, ESG analysis. There is huge, every sector you look at, there's a serious engagement about how we can and might make use of it. And if we look at the deployment just in the past year, what excites me is that from science and mathematics itself, we're seeing progress. And a particularly interesting class of progress is represented by alpha geometry. Whether you're aware of this, this is, again, DeepMind released research published in Nature, where they're showing the performance of a hybrid model of symbolic and sub-symbolic AI. So this is, again, the very interesting thing. I alluded to this last year, that we're going to see a melange of methods, a mixture of methods from a traditional world of AI, good old-fashioned AI, the kind of stuff I was taught by my professors back in the day, theorem proving, through to the deep neural network formats we have. And in this system, essentially, the system's trained to solve really non-trivial problems. These are international Olympiad problems in, for example, mathematics. Now, you will talk to any mathematician who'll say there's a big difference between the Olympiads and actual mathematical discovery. But when you listen to how mathematicians are now beginning to incorporate machine assistance into what they do, even in mathematics, I think you get a sense of the excitement. I don't mean that in any disparaging way. Wonderful. But I mean, you might think that that would be the area where people lock themselves away with towels around their heads for 5 years and come out with this extraordinary result. But they are also beginning to use these tools effectively. So this is exciting. I like the hybrid symbolic, neural symbolic integration. But then you go to content creation, and this is just one I saw the other day. This is an AI trailer. They have competitions for AI trailers, fully synthesized script, and actually it's clearly produced with a very smart human eye to pull this together. This is real Da Vinci Code stuff, this particular trailer. But you look at the quality of the output, the fidelity of the integration, the way in which scenes seamlessly move, and you are seeing an extraordinary revolution in this space. Now, just one or two alerts, because I think that's part of it. Although we are extraordinarily excited by where we stand at the moment in this age of generative AI, there are a number of challenges ahead of us. And as chair of the Open Data Institute, I would say this, wouldn't I? But one of the big, interesting questions is the feedstock of all this is data. And there is clearly evidence that we might be running out of it. Okay, well, if we're running out of human-generated data, what do we do? Well, perhaps we get more humans to generate more data. Probably won't solve the problem in the full term. We probably need to look at that data we're using rather more carefully and work out whether we are using it to its full extent. That takes us back to the trading regime trade-off that we talked about earlier on. But there are approaches. People have said, well, let's generate synthetic data. That would be a good idea, wouldn't it? Or let's have the systems work off their own data. We'll come on to that in a minute. Or you can learn from data-rich domains. Worlds of data locked away in genomics databases, for example. So you could imagine extending the runway in that way, or indeed just look for more efficient use of the data you have. Really interesting work looking at whether or not all data is not born equal, so that very high quality curated data doesn't have a particularly significant value. And there's active research on this. I think it's super important that we're exploring the strings of data and how they're used. We do know, and this is work that's really come to the fore, I think, in the last year, that strange thing happens when you allow your models to consume model-generated data. Artifacts begin to appear. There's this wonderful phrase, mad. Your models go mad. Model autophagy disorder. They eat themselves. Okay. As you can, of course, the papers present some extreme cases in which generation after generation is fed on the same output, but they collapse kind of interestingly. Or they regress to the mean, which is another interesting phenomena. The distributions at the end are clipped off. Often that's where interesting data is in actual sample. So we're going to be looking at, I think, a lot more work around the whole idea of the stability conditions, particularly of synthetic data. Big area of active research, but there are issues that we're going to be needing to look out for. A world of opportunity for researchers, I should say. Now, just about 8 months or so ago, I was giving talks around the concept of error in these systems, not to denigrate them, but to simply draw our attention to the realities of these systems as statistical approximators. Okay, so what happens in that world? Well, what happens is that it couldn't used to be able to do sums. You could give two big numbers to ChatGPT, and it would give you a variety of responses through time, some of which occasionally were right, but most of them were wrong. Of course, what happens now? Smart, let's call up a little Python calculator and let the computational method that does sums really well do its thing. You look at summarization. Leaderboards will vary about just how good systems are about summarization. How much is hallucinated or injected that wasn't in the original summary documents. Still a challenge. Things have improved, I should say. You're talking now about error rates for the best models around about 2% of content, but that's 2% of content. Could be a supercritical fact that's been injected in there. You might need to check it, etc., etc. And there was for a while quite a lot of chat around how good was the software-assisted coding. And I think it depends how much you're paying for your service, actually. That's what I would absolutely say. And we've seen in some of the latest releases and the evidence being collected from the community that there really are powerful assistive modes in programming. We'll hear more about that. And given the benchmarks that we're seeing come out that look at coding as an enterprise in itself, we're seeing some really quite interesting developments. So this is a thing to be always alert for, and hugely important in the kind of data literacy we promote. These things endogenously contain potential error because they're approximators, and exogenously there's a bunch of problems that may result from poison data, consuming their own data, etc., etc. So that space needs to be understood. Apple just last week put out a paper, this constant interrogation of just what are going on in the models. Again, I think I said last year, in a sense, the science is catching up with the engineering. And as we understand what is going on, this was a fairly an interesting paper, but it was just pointing out that the systems don't reason in a classic sense. In the case of alpha geometry, they actually do. What's interesting there, where the theorem provers are used, that's deductive that's closed under deduction. So you've got some guarantees about what the systems are concluding, how they're inferencing. But in other cases, you can trip the models up, and you can trip them up in some quite trivial ways. Fragility of mathematical reasoning, and I think it's important then that we distinguish what style of inference that relatively different methods in AI give us. So this space of all the AI methods we know about that have been developed ever since the field began, it's horses for courses. And In the latest reification, which is agentic AI, that's an old idea. You know, you come back to the notion of encapsulating a large language model as if it was an agent, and then you think about coordinating and orchestrating this community of agents together. So lots of areas where we see the rush, a new generation of researchers re-engaging with some quite traditional ideas. And just to wrap up, what are the other challenges? Well, Cassidy was referencing the societal impact. We've got regulation cracking on, you know, right through to the, back in July this year, the UK consumer duty comes into effect for insurance and financial services. That's going to impose a set of constraints. The ICO, the European AI Act agreed. This is a complex and evolving space, governance regulation. You're talking about it, giving it time here as you must. And in all of this, the societal impacts, well, everything from content creation, I've talked about that, wonderful music being created by these systems. The humanities, I think, are in good shape, not least because we'll constantly be worrying in our departments of philosophy about whether these systems need to be accorded rights or what they're telling us about the understanding of the nature of consciousness. Tons of stuff there. We're using it routinely in our science, everything from protein folding to deforestation to astronomy. We're using it on our healthcare systems. And of course, we're using it to kill one another. So the weaponization of AI being the forcing function of conflict has always been an accelerator in technology, and we're seeing that right now in various confrontations playing out, not least in the Ukraine. And ongoing cyber attacks, which are also, many of them being inspired and driven by AI systems. So, Cassidy's own work, disinformation, fakes, how are we to deal with this? And I'm really encouraged to hear the progress we're making here. And I would have to do this, wouldn't I? Naked self-interest, plug for the book. As If Human, The Ethics of Artificial Intelligence, available from Yale University Press, fine publishing house. We don't just... Roger and I try and come up with some organizing principles for how you manage life in an age of intelligent machines, life in the... And the metaphor, the overarching metaphor, this is not to say the machines are awake and thinking about their moral stance towards us. But if we judge them in the same way we hold ourselves to these moral standards, it becomes a very powerful operating principle. The notion of respect in an interface is not some kind of abstract concept. You can actually engineer those principles in. And the first overarching principle we come up with is exactly what our friends in C2PA are thinking about, which is provenance. A thing should say what it is and be what it says, so that we have this sense of confidence about what we're interacting with, the chain of ownership back. Show respect for human beings. Embody the best human values. This may sound high-minded, but it's an aspirational set of design features. Oh, technology is neutral. It's not about ethical choice. It's absolutely about engineering the values in. You see, the great thing is, it's not the artificial intelligence we need to worry about. I won't say natural stupidity, but it does lead to mine. Anyway, here we go. Should be transparent, yeah. Should have the right to be judged by humans if they wish. These things are starting to appear in different manifestations. But the key thing I would say, and whilst we are variously expert and moving the field forward here, decisions affecting a lot of people should involve a lot of people. And I was privileged to be at a meeting here around the whole idea of how you have more inclusive discussions in this space, in the space of tech. I know it's on the mind of a lot of you here. We cannot allow the future of humanity to be decided by either a technocratic elite or a set of vested interests in private. And that's a duty we all have to take seriously. Thank you very much.